Hello guys, this is a short video. It's a short experiment I was doing. Previously I made a pause menu and I made it so that when you press pause in Bizarro Untergrund, for one instance I grab the last frame and I blur it with a very dirty blur, which should still be very taxing for the CPU, but because it's just one frame, there's a very short delay. And we were talking about optimizing it in assembly. Trap Exit in the comments was talking about that. So I was curious. I was curious about doing some silly experiment. That is, I'm not gonna include it in the game. That's why I, for now, do not pollute the code and then define. I wanted to see if I could blur every frame in real time using the CPU, of course, and how fast it could go. I mean, it's not very fast, and I did some. I wrote it in assembly. Let's see what I did. When you enable the heavy blur experiment, I have this. We'll go back to this later. This is the game loop. And I have my special function which I can switch. I can tell when I call draw cells, for example, if render to buffer is on, it's gonna render to the buffer item. These are the back buffers I set up, and I have set up two off-screen buffers and 4 RAM buffers, but I only use one off-screen buffer. Now I set up the 4 main buffers to avoid flickering because to check the full video RAM, I do noticing it. I don't clear the frame. Although I don't think I could still clear the frame, but this would produce flickering. So anyway, so all I did is to, if I do the heavy blur experiment, is to switch render buffer. So when later I call draw cells for all my polygons, they are not gonna render in the main video RAM. They are gonna render in the back buffer I selected. It's the first back buffer. So after the whole loop and the rendering, probably run or grid map will start doing transformation and rendering the polygons and everything. The UI also render the UI, everything in the back buffer. And now, if it's so, I copy the back buffer to RAM, and I also switch render to back buffer to 4 so that I can draw cells again on the main screen. And that's also because when I say display debug number, I'm really rendering the frames per second, and I don't want that to be blurred. I want to render it back to the main video RAM. But this one will copy the whatever I rendered with the cell in the back buffer to the video RAM, and I think this is the software rendered version. And initially, it was the man copy. Oh, I never changed that. Yeah. Yeah, I did some changes on the other side, we'll see, of the 3DO. Now, you see the same thing, but I'm rendering, draw cell is rendered to the back buffer and back. And you see, because I'm not erasing the last frame, I get this. But even if I was erasing the last frame, I was using sport, and sport was pointing to the video RAM buffer. It will still not work in my experiment. Yeah, and so when I do that, this is on the PC board, so it's gonna be fast. It's a blurry shit. It's a blurry mess. Oh, yeah, that doesn't work. You know, because it's an experiment that I fucked up. So everything is blurry. And that's a very dirty blur, of course. And you see, it doesn't blur in the edges so that you see some artifacts above and below. Maybe on the left and right side. Some of the stars that I still render in the background. But that's just an experiment. It's not something I will ever do in the game. Can I render in real time? And that's here. And maybe we can see what I do. I unrolled the. I think I showed you that before. I even unrolled the code. I simplified things a bit. I read the 32 values, which is 2 pixels at once. Up, down, left, right. And I did some bit arithmetic before. So that, because this is a dirty way to shift and add the values of one pixel would bleed on the values on the other pixel. Also the values of a color channel. Unless you do some correction. It's a bit of a dirty optimization. Normally, the way you normally do this algorithm is get the 16-bit value, break every pixel individually with you do it. It would need much more. If I don't do it dirty, it would be much slower. And even now it's slow because you know this arm is not fast enough for full screen manipulation. And what I wanted to show you, oh yeah, I just wanted to show you again. You know, I don't know if I can depict it. So the 3DO video RAM, the pixels are like this. Let's see if I can do it. Okay, the pixel goes first pixel at address the start of the video RAM. First 16-bit value. Second. Okay, the pixels are like that. Can you go down? So when you read the video RAM linearly, when you write in the video RAM linearly 16-bit at a time, it goes like that. Goes there, then goes there, then goes there. Goes in a zigzag pattern. It doesn't go in a linear way. So when you write a 16-bit value at this address, it writes this pixel, pixel 0. When you go to the next 16-bit address, it writes the one below, then goes above to the next pixel, and so on. That's how the video RAM is. So that could make things a bit harder. But that means when I read 32-bit value so that I do 2 pixels away, it's gonna read this pixel and the pixel below. So when I do blur, normally in blur, if you are at pixel 0, or suppose you are at pixel, I don't know, 5, you will read, it depends, you can read any kind of pixel. You would read the above pixel, the left, below, and the one below. You will add them together and divide by 4 or shift right by 2 to blur the value. But now I have this thing. I am at this pixel. I do minus 4 bytes in address, so I read left, right, and then I read up, down by adding all of this 32-bit 4 bytes. So I do minus plus 12080. However, because this is a 32-bit pointer, I do plus screen width 320 here. But now this is in bytes. So now I go up very high. I go 2 pixels above and 2 pixels below. Because you can, if you pointed the address here, it will get this pixel and this pixel. You could do some interesting configuration. Now that gives me an idea. Wait a minute. However, this would be wrong because it would be not aligned. You wouldn't be even able to do that. You would have to read this, this, and this, and break the pixel. Do extra bit shifts to get the individual pixel here, the individual pixel here. So now my thing is taking 2 pixels above and 2 pixels below. And that's why sometimes you see that in the distance my mouse is captured. I can't even point. You will see it in the patterns. You will see even here that there are some scanline patterns. So it's a dirty blur that does. You see there is something that repeats here and interrupted by half scanline in the distance. Because it's interesting. So it's a very, very arbitrary, very dirty blur. It's not a standard blur that you go by the book and say, okay, I need to get this exact pixel, individually and break them. So I take an advantage that I grab a whole 32-bit value and do some addition with an additional end with a value. And now I decided, just out of curiosity of how slow it will be, I decided to port this on the 3DO. And let's see. You can see all the version. And I'm going, of course, I'm going to remove that or comment this out. Even remove that. This was just a silly experiment. And I haven't finished with the experiment. So let's see the mem copy version. I haven't optimized the darken version in assembly. It would be easier. But normally the darken version, I could use the cell. I could grab that frame buffer frame with the frame buffer, the back buffer, and use it as a cell texture. I wouldn't even need to do the hardware manipulation and use the PIXC, the function that can give you blend, darkening, brightening. I could do it like that. I don't know if I could do some blur with this. I can do a motion blur by blending the previous frames. I could do other things. So I didn't bother with this one. Let's see. Why I have mistakes? Ah, yeah. I'll show you something else also. Let's run it on Phoenix. Or maybe I'll show you later. I'm going to speed up. I'm going to put the fourth level. You see, they are still a bit flickering because the frame rate goes crazy. Okay, the actual frame rate. I'm doing the mem copy here. Still good. The frame rate hasn't been. I don't remember what's the normal frame rate, but it's not much slower. So this is the cells are rendered in the back buffer, and I do a mem copy using the CPU from the back buffer. Back to the. And now it's time for the. Okay, this is the C version, which I also unrolled a bit. I wish I had the button for that too. And right now I'm gonna show you something else. Don't look at the frame rate. Look at the frame rate now. Yeah, and that's how bad it is, like 7 FPS. I I'm blurring the whole thing in real time using the CPU every frames. That's funny. I look at the other thing that's irrelevant. I noticed that already. This is Phoenix, okay? If you run it with 4D, there was always something wrong with the. Okay, I'm running it overclocked now, but I'm going to put it back to normal. There was something always wrong with 4D in the CPU. And in fact, the performance in some cases was worse than the actual 3D. So if you do something and you don't get good, especially on this good frame rate to the 4D, something no cell specific CPU, you might be a bit luckier because 40 goes on 4 FPS for some reason. From 7 to 4. And that's also my assembly equivalent version, which is not much faster. It also suffers. So sometimes at the normal CPU speed, 4DO is slower than even the original 3DO. It doesn't count the cycles well. We might be gaining some cycles in certain cases that the 4DO doesn't account for. But you have to be careful with 4DO because it also doesn't account for cell cycles in the other way. Things run much faster if you do cell rendering. Things that are performance intensive for the cell, they will be much faster in 4DO than the real hardware. You will run it later on the real hardware or maybe on Phoenix with cycles. Even Phoenix is a bit fast. And you will be disappointed, like, oh, the real 3DO is not as fast. 4DO doesn't care. But 4DO is slower with the CPU for some reason. Even my assembly. Oh, that's the pause background. It's not. It's. We need here the copy. The pause doesn't work now because of the still experiment. So this is my assembly function, and I haven't done the full optimization. I'll tell you why. I haven't managed to do an LDM to load many pixels at once, many words at once. And I might not do that now because it distracts me from the game development. It's a bit more tricky if you're doing a blur. I'll tell you why. It might be easier from a VRAM. This is the VRAM copy. This is not the one I use. I use the regular mem copy. I don't know if hmm. Why do I have this when I can use mem copy? And this is very hard coded also. Now you got me curious. Sorry, you got me curious. Did I figure out that mem copy is not as fast the default mem copy as I thought? It wasn't the best. Now my VRAM copy is a dirty one that says I need to see that destination. It's the same, isn't it? And I have arbitrarily unrolled it. So this is not a generic mem copy. This is just a very lazy one. This is not one that will, okay, if you give me any size, it will not work. I just wanted a lazy one to clear a specific buffer. But why did I make my own? Wasn't mem copy and memset, the default mem copy and memset, optimized enough? Interesting. So wait, length. Yeah, I length is R2 and I subtract 256 because I unroll this 8 times. Unroll this 8 times by, and it has 8 registers. Read 8 registers at one and copy them back. So that's 32 bytes by 8, 256. And of course this only works properly if you're 320 by 240. this works if this was divided. This is divided well by 256. So the size the size for the video RAM is okay for this very dirty. But I want to see. Okay, first of all, again, I want to see that. I want to see that. I'm gonna see the frame rate, the regular, in the first frame. I'm gonna put it. No, wasn't it too buy? So the regular mem copy at this frame, at the starting frame, 22. My dirty RAM copy. Why would I use mine? Usually mem copy and mem set is optimized for the platform, but sometimes they are not. Sometimes surprising from official SDKs and oh no. I'll be damned. 25 from 22. This dirty thing, which is not a complete mem copy for any kind of any arbitrary size. It's a very hard coded just for the video RAM. This thing is faster than a regular mem copy. 25. 25 at this frame. I'll be damned. Okay, interesting. And now let's go back to the assembly routine. Now the assembly routine is this one. I have unrolled things. I managed to collect things and R6, R7, R8 and R9 so that at least I do an STMIA to write 4 words at once. That means 8 pixels. So I close that. So yeah, so if my pixel were 1, 2, 3, 4, I would write those pixels, bump, and then those pixels. But what I wasn't able to do, or I can do but it needs more thought, is to also LDMIA, read multiple pixels at once, because you know when, maybe I can use a brush. Yeah, that could be. When I when I blur, first of all, it's pixel at 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 address at the beginning of the address, the next address in 16-bit. It goes zigzag, lang, 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 lang. LDMIA, it will sequentially read, and when I'm here, I want to read the pixels to the left, pixels to the right, above and below. Now, I could do an LDMIA and read 4 words at once and read all this pixel. But then I have to unroll the code so that I have to keep them in registers. And as I move to the right, I have to write some more sophisticated code. Be like, okay, maybe this is on R4. R5, R6, R7. I would have to say, for this sequence, get the one to the left and to the right. Add them, add R4 to R6, but you also have to add the above, so you would have to put the pointer of to do another LDMI above. So it's not so easy to do some clever LDMIA. But suppose you want to do only left right. In the next frame, you have already read it, all these 4 pixels. In the next frame, if you can keep them on register, you can say, okay, now add R5 to R7 and blur them. Now add R6, okay, now I have to do an LDMIA here to get the next. And if I do, I'll get 4, 5, 6. No, we still keep 6 and 7. So now I have to do LDMIA for some other 4 registers to continue the pattern. And this pattern will repeat. After 4 pixels, there will be some modular. It will go 4 plus 6, 5 plus 7, 6 plus 8, 7 plus 9. And when you reach here, you will do an LDMIA. You will be far away. R4, 5, 6, 7. So you could do some sophisticated, very specific. But that's for the horizontal, where you will alterate the registers. And because as I move to the left and I read left and right, I'm reading the same memory twice. So I could cast things in register, but the pattern will be a bit more of it. It needs a bit more thought. We've done this before on the Z80 when we were doing this was originally Anditex idea. That was my old CPC demo. I'm putting the sound down, and we were doing some really cool blur fire effect, and it was Anditex idea that, but the pattern was different for the fire. The pattern was, you can find different patterns. Where's the brush? The pattern was uh, this pixel. So the pixel you are in, left, right, and one above. So we had a pointer maybe here. You have this is a 16-bit register made of 2 8-bit registers. We could have something like that, and maybe BC would be pointing up, and maybe BC would move and read this one, and then here we would do something like the load a and the decomagel. No, why is it so big? But then you would also do engagel, maybe, or maybe we did the pop. Damn it, pop BC. Although we use BC, but maybe we used BC for something else. So we would pop 2 bytes at once in our blur buffer. And now, anyway, I went a bit far from. Now, this would be A, the register A, this would be D, this would be E. But we unroll the code, so in this section we would reuse D and D and load something there, some other thing. And maybe this was not A, I don't remember how we do. Maybe there are not enough register. Maybe we used BC. Because we have to add, we could do LDA, add B, add C, and then add the above. So we did some kind of repeating pattern where we would reuse, we wouldn't read again when we move in this section. We wouldn't read again 3 times from memory. 2 of the 3 would be kept in register. We did something clever like this. And maybe I would need to do something like that here, but I didn't do because it's a bit complicated now to think about. And what about the pixels above? But we have that Tetris pattern, like a Tetris space. That was enough for a fire effect where the fire goes above. There was one of the pixel we read was above, the other was the central pixel, and that made the fire go a bit up. So you can do different kind of blur patterns, but here we do some a more simple one. So there are multiple. That's why I could never do the LDMIA stuff. Instead, I did okay, just a regular load, 4 loads, up, down, left, right. No, so as we move to the right, some of these loads are pixels we already read. So there is potential for optimize this. And I'm doing the typical stuff. I had to calculate, and that's better also. This magic number and this magic number I have to end. Ugh. I had to prepare them once at register 10 and 11 so that I can reuse them below. And I don't have to cost, especially on ARM. ARM has this thing. You can say move R1, you can say move R1, 0, 1, 2. Put a value in a register 255, but the registers are 32-bit. Can you do something like that? Can you put a big number? Unfortunately, no, because the way ARM works is that every register, every instruction has also to fit in 4 bytes. So there is an issue. If I try to compile this with a big number, the immediate value is out of range for this operation. You cannot put any immediate value, which is, it's weird if you came from x86, from Z80 even. Because they want to keep this in 4 byte. Because if they allow this, there would be 4 bytes for this instruction and extra bytes for that instruction. So they are only a limited amount of values. And the values that work are a value that fits from 0 to 255. This is the theory. 8 bits at most, but shifted by another value, which I think is, let me think, I think it could go till 24, maybe it goes till 31. Shifted by a few bits, because I think this one is a number from 0 to 30, this one could be 5 bits. Maybe it's 5 bits. So some numbers work. So if I put 512, even if it's a higher, sorry, the syntax, you need to put that for a immediate value. It works. If I put 511, it's out of range. And that's if, of course, now I'm giving you a primer on because the 512, it's this one bit shifted to the left. The 511 happens to be 9 bits. So those 9 bits, you see only the most left one and the most right one. These are not fitting. A 500 would fit. You start from the rightmost and count 1, 2, 3, 4, 5, 6. This would fit. And if you had something like this, would be from here 1, 2, 3, 4, way over. It's a big piece. Because that's what the arm does. Your value, if it fits at least the ones, okay, the ones and the zero in a range where the rightmost one to the leftmost one, because it can represent that in a value that it can shift it, and it could be 8 bits and I guess 3 bits for the shift. I think it's 3 bits for the shift. Yeah. So because these values, sorry for the they cannot be put as immediate value. You have to construct it. That's what I guess a compiler would do. So I see that this is a pattern that repeats on the higher, and the 8-bit value is EF and 1C. So I do it in three steps. Move R10 EF or R10 with R10 and 1C. Now this seems like a 16-bit value, but it's really 1C, it fits into 55 in 8 bits, and it's shifted left internally on the CPU. It's lifted, or this instruction is going to shift it left by 8 bits. And now I have constructed 1 CEF on R10, and I simply need to or R10 is there is an R10 with R10 and shift 16 to construct the NCF. Anyway, I should have comments, but maybe it's not needed. And I do the same for the other magic number. And now we have on R10 and R11 the magic number, so that I don't need to do this whole thing here just to, and I cannot directly do the end. Also, a nice little trick would be not a trick. When I was doing this one, I calculated this one first on R5, and you would be tempted to say, okay, I need to end the R5 with the R10. And then shift it by 2, which is what it is. No, I shifted by 2 first, and then I end it. So you have to shift it. You have to do mover LSR2, and then enter 5, R5, R10. But I do it in one go for the simple fact that, sorry, I'm setting the fact that this one could also be, you can change the order. It's the same thing. It's like addition, where you can change, it doesn't, or multiplication. It doesn't matter if it's left or right. So initially I wrote in and then I realized, okay, I can do R5 is the result, but we also read R5, but it's also the argument. R5 is this, and R10 is this. So end it from the left side, comma R5, and because this shift in the same function can happen as a shift R5 by 2 and end it there. If you did it the other order, you wouldn't be able to do something. This doesn't exist in ARM. It's only on the argument on the right side. So there are little things like that. Let's see, because I might have missed something. And I unroll it many times. I put the result in R6, R7, R8, R9. I missed it. Yeah, I'm doing the whole thing basically in as little assembly code as possible, I guess. The destination will write linear, but this one I also this exclamation mark says load. Okay, you load from R0 plus 4, and then it's like it did R0 equals R0 plus 4, and that's to move to the next, so that the source here goes to the next word. Now I could have done add R0 R0 4, and initially this goes up here, minus 4 plus 4, because here I am doing the minus 1 plus 1 plus screen width minus screen width. But I realized I don't need to do the add, because in the last read the value plus 4 and then update R0 with the increment. So that was another one. I moved this read of the pixel last, so that I can do the increment for free. So with this thing I try to optimize as much as I can, collect the 4 pixels and do an STMIA. And you will see that it's still not enough. Now in the future I will try some LDMIA thing with some complicated, you've seen the complicated, I don't need to show you again, schematic where after unrolling 4 times I can cast some things in certain register. I hope I have enough registers. So now are we checking this one? We're using this one. I haven't seen the generated assembly code from the compiler, but this assembly solution isn't as fast as I would expect. Now, did the previous one did 7 FPS, 7 frames per second. This one, as you can see, this one does 8 frames per second. So, okay, we gained 1 frame. And here it's gonna do 7 FPS when the geometry becomes, obviously, because of the overhead from the cell and the transformations. So, despite oral attempts, so maybe if I did the LDMIA version, which is more sophisticated, and probably I won't do it now because I want to focus on the main game development. This was an offshoot experiment. I'll do one simple experiment. I'll do something dirty. You'll see. Hmm. I could do plus equals 2, or I could do screen height is 240. Yeah, yeah. I could do half there. This is 56, isn't it? Yeah. And I'll do this now. I'll do this magical thing. Oh god, it's even up down pixel in this zigzag pattern. Ooh. That's gonna be more dirty. I'm going to do some half scan lines hack so that every time I blur half of the scan lines, I'll see how it goes. I think this is something I could try easy. Start again. Yeah, just put something. I'm gonna do a flip, not even flip. The source and the source and destination. Syntic by. Yeah, maybe put some. Is it odd or is it even? Hmm. Yeah, it's simplest that. This is gonna be 32. And this is gonna skip even. It's not even scan line. It's two scan lines because of the zigzag pattern. It's two scan lines off. I'll even try the initial first. Oh, my god, no. Again. Damn it. This is the pause menu. This is not the actual thing is here. Damn it. Okay. So I'm doing half and half scan lines, alternating. I want to see how it is gonna look. And there is one more change that he's. No, we did it here. After we finish one scan line, we skip a hole, and it's two scan lines. So you're gonna write pixel 0 vertically, line 0 1, then line 4 5, then line. It's gonna skip every two lines. Hmm. I'm curious trying that. I'm curious how this will look like. It's gonna double the frame rate for sure. This is not the normal way to do things, obviously. Just if you do demos and stuff, sometimes you are gonna experiment with dirty ideas and say maybe it does something interesting, maybe not. Oh my god. Oh my god. It's like a TV screen. But the scan lines are so thick that no, I can't even see the frame rate. It should be double. No, that's bad. And you have the star. I still render the stars in the back. Now the thing is, the stars are rendering in the. It's a software rendering direct in the video RAM buffer. I get the video RAM buffer and I render. So it's not using the draw cells commands. No, guys, that doesn't work. I can. Is the frame rate 12? And then the frame rate because I have to clear. I would have to go. In my engine and do that. Maybe also, what if you don't clear? What if you render the previous scan line in a second buffer? You know, I'm not gonna try that now. No, I'm gonna. This is annoying. You know this loading. It's gonna go away. I'm gonna do it on PC. And it's the refactoring I wanted to do in the future too. This loading, which is mostly the calculation of the lighting on the 3D side, I will offload it on the PC. Okay, now because we clear, okay, we are 11 FPS from 7. It didn't even go double or 12. I don't know. You could make some LED screen somewhere, but it's two scan lines because of the video RAM. You couldn't be able to do fast half and half scan line the way the 3D video RAM works. You have to get 16 bytes out of 32 bytes, and wow. Okay, okay, I tried. I tried. I can use the assembly for my pose. Right now the pose heavy blur experiment. So now we don't do switch render to buffer, and the pose works with this. So I could use the assembly version, which probably is shorter than this one, even if it's still unrolled. Shorter and slightly faster. Let's see now if everything came back to normal. And this one operated. This is when I pause. That's why it doesn't work now when I switch. It operated with source the video RAM, destination the back buffer. And later I was setting the back buffer, the blurred back buffer, as a background. This is setting the sport, the one that copies blends the background very fast. And on top of it, I was rendering the UI. And that's the final experiment for now. It's like 7, 8 in the morning. I woke up. I didn't have breakfast yet, but it was 6 when I started, or 6:30. I don't remember. Uh, let's put that. So that's the normal. And do you remember we did 22 or 25 with an additional mem copy? Now we do. Okay, so now I write directly to the cell writes directly to the video RAM. There is no. Except for one thing. We get 34. With my fast mem copy, we go to 25. With the regular mem copy to 22. And if I press select, oh, it still doesn't work. I must have broken it. I'll see what I did. Also, oh, it might be the clear. Is it that why? Interesting. Maybe that's the. Yeah, if I don't, but no. I'm clearing with the. Did I broke it? Did I fucking broke it? Come on. I'm using the assembly function, but no more heavy blur experiment. Shouldn't that? It wouldn't work. Doesn't grade out this editor. So we don't. This is not happening. This is not happening. This we forget something else. Where is it? Prepare menu and background. Blur menu. Blur. Source destination. You read the RAM buff. Now it depends on which one, and you write to the destination. Oh my god. How did we broke it? I need to see that later, maybe. Oh, no. Oh, because we don't clear the unconfused. And also, because we clear now, we have to clear when we look at blackness. Nothing is rendered. We have to clear so that it doesn't become a messy mess. We have the stars and everything. So now this is the assembly. So there is a delay when I press. When I go out, it's faster. When I press, there is a bit delay, but it's very little. It's alright for a pause menu. But so when I don't clear the frame, oh, why would why would that do what it does when I don't clear the frame? Because when you copy, when you pause, I blur in one case I blur the back buffer just once, and now the frame buffer. It's on the back buffer, and now I have set up a sport copy that it will always copy this back buffer. I never touch this back buffer again. I never clear it again. And it does a regular copy that will. Oh, what? It's not even blaring now. What? What? Didn't didn't I previously? When you do that, I've blurred the thing and it's not even blurred. Why is it not even blurred? Wasn't it previous blurred? What the fuck? Ah, what's going on? I run 40O, but just to make. Oh god. Set, okay, set clear frame. System graphics. Where are you? Where are you? This tends to be bigger than clear frame on. What happens if clear frame on? Oh, okay. Oh. Yeah, it doesn't even do the sport copy. Now this sport copy is either clearing the background or writing back an image. That's funny. Yeah, fine. As let's do static bool is question mark something. Or we don't. So if we set this, yeah, that's an now I could do many things. I could try to read one of the values. Ah, yeah, I can read. Okay, you know what? I think it's nicer to. It makes more sense to say if it's flush right. if I say clear frame, or if this is not true, but the command is not a flash write, you will still do the IO copy. Yeah, I think that's gonna be. Oh man. And final. What am I doing in my morning? That's fine because I can pause this experiment and progress with the actual game. It was fun and interesting. It's been a long since I last wrote R. Maybe that's not true because I did some Archimedes thing, but I was still trying to remember. Yeah. So actual speed. Oh yeah, I'm not clearing now. And because I'm not clearing, whenever there is sky background, but here I don't need to clear. You know, that was a thing with OpenLara where if you clear, you either head to vsync, else you will have flickering, but my other thing that takes memory, if you have many video RAM buffers, now I use 4 and say, you know, maybe I'll put 2 for the off-screen buffer. I could do some cool stuff with off-screen buffers. I could do portals. This is something I'll try in the future. Like in Duke Nukem 3D with the cameras, or even I could do some portal that looks in another place, but that means you have to render the scene 2 times, one in the main, one in the off-screen buffer, and use as a texture. I could I could do some dual screen gameplay, two-player mode. It's gonna be half the speed. So maybe 2 off-screen buffers would be nice. You know, the maximum buffers are 6. I've explained that before. So we just set up the graphics. I have a nice system. And typically this is 6 because a frame buffer is 320 by 240, 16-bit 2 bytes, and if you multiply by 6 you go 9, you know. If you did by 7, I think that's over 1 megabyte. The maximum you can get is 6. And I think in PAL, if I get some PAL resolution with more pixels vertically, horizontally, I think you could reach 4. You could make 4. If you use the PAL high resolution, which is something that I could also try in the future. It would be glorious. So if I use 2, I will start to experience flickering, especially 1. But this is how I eliminate the flicker even if I clear the frame. Now I'm not clearing it even. So I want to clear it. Also, I think when I use the sport, when you use the sport right, where is it? The sport copy. Do I already do that? Oh, I already was doing the check. The one check I'm doing now. Where did I? Ah, flash right. Yeah, the one, check it directly and not clear the frame. I was clever enough to say, okay, if it's a spec copy and not clear frame, both of them. If not, and vsync, if you have vsync on, so there is a case, if you do sport copy, the 3DO hardware will automatically vsync. And if I didn't have this check, I will do twice vsync. I will do twice vsync. So I have some cool stuff here. I need to clear the frame for the star. I could have it that if the stars are visible, if there is some black area that's open and it's not covered with polygon, then I will enable the clear frame. But it's the clear frame is so fast. The issue was with if you want to disable vsync, and we disable vsync, but you need enough frame buffers. Now that might not be good for OpenLAR because memory is tight, and even here memory is tight. To be honest, I have to see what's going on with memory, because we might have some problem. And I'm gonna stop it now. I think that was enough of a nice experiment, explaining some things and so on. I'll go back to regular game development. I might keep this with the macro that disables them. So if I want to experiment, and maybe later I'll delete this. I can keep the assembly version for the pause menu, I guess. Bye.